talking about digital transformation, we're talking about something far more global and strategic in nature. What we're talking about is reinventing the way we do processes, whether it's an engineering process, an accounting process, a business process, HR, hiring and talent management processes, but reinventing those processes by leveraging all the emerging digital technologies and data management and big data and all the tools that are really coming at us very fast, to be able to leverage those and to take advantage of those, to reinvent those processes to be more efficient.
Hi, that was Douglas Terrier, our Chief Technologist at NASA. And my name is Newton Campbell. Through the Science Applications International Corporation, or SAIC, I serve under the Office of the Chief Information Officer, data science team at NASA Langley Research Center, where we combine our digital transformation thrust at NASA with the latest in artificial intelligence and machine learning. By doing this, we help scientists, engineers, as well as people across the enterprise take on new technologies that are rooted in artificial intelligence. Our work ranges from using AI for intelligent urban air aviation, to detecting cancer-causing space radiation, to developing intelligent dashboards that help the enterprise with decision-making. And as our group lead is helping to frame the ethical AI strategy for the entire agency, we have the opportunity to be out in front with establishing processes and methods for advancing understanding of concrete ethical implementation of digital transformation projects. Right now, the US government is going through a large-scale data transformation effort. The GSA playbook is guiding all agencies to make their processes data-driven with the help of emerging technologies. At the same time, NASA leadership wants to share best practices in digital solutions, avoid duplication and gaps, ensure interoperability among all our projects, and encourage cooperation among all stakeholders. With that in mind, in the spring of 2019, NASA leadership approved an agency digital transformation strategy with the Office of Chief Technologist leading coordination in partnership with the Office of the Chief Information Officer. Key elements of this strategy, this plan, include digitally transforming NASA's data use, collaboration, model-based work, administrative processes, application of artificial intelligence, and workforce and culture. Digital transformation will increasingly change the way NASA operates and enable the agency's missions to be completed more efficiently and effectively. And concerning this talk, allow future employees to use their talents in more innovative ways. Under NASA's Digital Transformation Officer, Jill Marlowe, the agency is making investments in nearly every sector to unlock any potential technology innovation. This comes through money put towards tech challenges, sponsorship of small technology programs to vet capabilities, and real strategic assessments regarding the use of artificial intelligence across the agency. Some examples involve us directly leveraging new technologies to do our job, like Oculus and HoloLens. Others include innovative use of open frameworks like InfluxDB to develop straightforward pipelines for processing IoT data. And as always at NASA, our goal is not to just do these things and use cool new tech, but to show how we use it to address issues that many groups face, like folks here at ARM or yours. One issue that we face in digital transformation, particularly as it relates to integrating new advances in AI, is that the investment of time and effort in obtaining things like product licenses, support, training, and other product-specific services can unwittingly tie some of our projects to product vendors for the duration of a project. This is a concept known as vendor lock-in. And it's something that I saw a lot of government agencies go through about 10 to 15 years ago, when everyone started talking more about big data in the cloud. And I'm now seeing us go through this with diverse data when it comes to AI, okay? When it came to the cloud, vendors were all about, we can take all of your data as is, slam it into the system, and give you all the compute functionality that you could ever want. No maintenance or troubleshooting of platforms needed. Fast forward 10 years later, it's now, we can take all of the data that you have stored on that cloud instance that you're still paying a support fee for, intelligently fuse all of the other data that you've been trying to store for the last 10 years that's still not structured, and use artificial intelligence and machine learning to make sense of it. In either case, the common theme is for the vendor to hang on as long as possible. Makes a little more sense in the cloud case because, well, you are hosting data or a service on their platform. However, in the case of AI, you're tying the logic of your project, not just the workflow, not just the platform, but the logic of your project to an organization with inherently limited capability. With so many of these fairly new AI capabilities coming out every day, you risk coupling your own software implementations tightly to a vendor's API, their application programming interface, or service. And suppose you fail to make incredibly nuanced purchasing decisions and system design decisions. In that case, you can easily incur high operating costs for AI toolkits of vendors large and small, while simultaneously limiting your capacity for data science to the capabilities of a single vendor. And those effects can be more impactful in organizations that don't have a trained data science staff on hand to sufficiently augment those vendor capabilities. And that is just an impossibility for many organizations. So with respect to these themes, we're building Endeavor, the environment for data engineering in virtual reality. We love our acronyms in the government and especially at NASA. This is funded under the Act 2 digital transformation effort, local to NASA Langley Research Center in Virginia. The goal of Endeavor is to Act 2 digital transformation effort, local to NASA Langley Research Center in Virginia. The goal of Endeavor is to develop an applied mathematics and data science ecosystem that allows users to command and investigate customizable data analysis from a virtual reality environment. It's a VR data and applied mathematics lab for the NASA employee. Endeavor permits a user to load and quickly pre-process data, develop a data processing pipeline from a VR environment, and then kick off that computation of that pipeline on a back-end compute server. It then allows the results of this pipeline to be explored using existing VR capabilities. A vital feature of the Endeavor ecosystem is that it's not dependent on any one particular proprietary data science platform, allowing users to extend its data analysis capabilities without restriction. The users construct a pipeline, a data pipeline, using hand motions by organizing a set of data processing widgets from the Endeavor algorithm marketplace. Again, from a digital transformation standpoint, the intention is for the agency developer community to contribute and grow the marketplace over time, adapt to new diverse open source or proprietary data analysis libraries, and inspire collaboration across centers. This will allow users to easily create modular data pipelines where they can easily have access to new implementations of similar operations attached to different vendors. They can easily swap up access to new implementations of similar operations attached to different vendors. They can easily swap a part of the pipeline out if their project has a need to change vendors. They can also download the code of an entire pipeline, allowing them to take it outside of the environment. The full system is still under development and test at NASA. It's been developed and tested as a multi-tier system built on the power of the Oculus VR and Unreal Engine. And it's extremely extensible. Its communications infrastructure is built on things like protobuf, gRPC, and WebSockets. These capabilities allow us to continually add features like the ability to easily ingest real-time IoT data, mission data, or lab data, or to quickly pass performance information from machine learning models into the virtual environment as needed. So much of the AI on board Endeavor is being prototyped by our development team this fall. However, as this system is implemented, we as NASA community members are trying to be aware of the ethical implications of building such a system. One of the first of many studies that we looked into prior to NASA's own AI ethics framework coming out was ODNI's, the Office of the Director of National Intelligence, their framework for ethics. And in asking ourselves some of these questions, we realized we had to focus an ethical analysis on certain components and features of the Endeavor system. The two primary AI-focused components of the Endeavor system are the intelligent assistant and the storage and execution of arbitrary algorithms, that overall concept of algorithm sharing. The Endeavor Intelligent Assistant is a form of AI native to the Endeavor platform. We are combining logical programming with category theory, an advanced field of mathematics, to assess properties of user uploaded data to determine the best mathematical representations for analysis and visualization within VR. We are also planning to use this capability to tell the user in specific scenarios that, hey, you may want to try this algorithm or convert your data to this kind of mathematical representation to achieve your desired outcome. If unchecked, however, this can easily lead to certain biased recommendations and introduce blind spots to analysis. And the second is the more general concept, again, of democratizing artificial intelligence within the agency. Remember, one of the key features of the Endeavor system is the ability for users to submit their own data science algorithms using an open-ended array of languages, platforms, and third-party libraries. And this will, by design, lead to execution of unknown or loosely understood machine learning code in one software or data analysis pipeline. Both of these are concerns that we must study further before full deployment of the system across the agency. And the third component is a bit future-facing, but it is an area of research that we want to pursue as something we can contribute to other programs within NASA. We have some pre-analysis work done and have some basic plans in place to pursue a framework for guided testing and intelligent validation within the Endeavor system. The need for a component such as this arises from the high level of difficulty inherent in automated testing scenarios within a human-centric environment such as VR, and as such, would be responsible for walking users through manual test scenarios. Machine learning would decide what scenarios should take priority here. And again, it's something where we can transition methods and results to other NASA programs. But we also want to understand any ethical ramifications behind using machine learning for this kind of testing. So just a quick aside on how this works right now within NASA. In 2019, a representative poll across NASA revealed over 100 agency applications of AI in the previous 3 years, with hundreds of AI projects planned across various missions, centers, and mission support activities from 2020 to 2022 and beyond. In November and December of 2020, the White House and Office of Management and Budget published guidance regarding AI principles, policy, and governance. As an enthusiastic and forward-leaning AI adopter, NASA created and has begun to apply an evolving living set of AI policies, principles, and guidelines to provide AI practitioners an ethical framework for their work. They just released their framework for the ethical use of artificial intelligence across the agency this past April. My team's leadership was heavily involved in the creation of this framework, and I can tell you, they pulled from a large number of studies and applications when putting this together. They officially established key principles for projects that are implementing AI to follow. The idea is for these to serve as a guide. A project should demonstrate an assessment of these principles before, during, and after implementation of the project, even during operation. When developing this kind of framework for an organization, as I've seen in other frameworks like DoD's or the intelligence communities, you have to have some set of high-level themes for projects to work towards. Ideally, any given project would develop its own quantitative metrics for those themes and the project's actual concept of operations. So throughout the summer, we started to compile our own preliminary ethics report for Endeavor. To do so, we had the development team go through iterations of reading and discussion over several months to give appropriate considerations to the subject. Their reading list included sources from the Department of Defense, the government's intelligence communities, European Union legislation, a range of ethics and security experts, and sources from within NASA itself. At the beginning of the summer, the development team was guided by a set of discussion questions. The key thing to remember is that there were several goals associated with this exercise. For the developers to learn more about ethical concepts and frameworks surrounding AI and its related systems, applying those concepts to our own system with particular attention paid to the Endeavor Intelligent Assistant and storage and execution of arbitrary code, and presenting a set of recommendations for future ethical development of the Endeavor system. Based on the findings from these discussions, the development team decided on the following recommendations going forward for Endeavor. First, You have to keep an explicit list of the parties within the Endeavor ecosystem, their assigned ethics and security responsibilities, and latest contact information. This one is pretty straightforward and allows us to evaluate accountability when incidences regarding ethics arise. Second, you have to maintain a list of vetted third-party libraries and APIs that are approved for use within Endeavor. The use of third-party libraries or platforms brings inherent risk to the system and its users. These potential risks include, but are not limited to, things like malintent, system sustainability, and security risks. Now, malintent implies that the library was created with the intention of harming the systems of those who use it. Perhaps most important to Endeavor is system sustainability, the long-term health of the system. In this context, security risks include anything that puts NASA at risk for a system compromise or attack. Maintaining a list of these libraries is a straightforward exercise for us and will allow our team to continuously evaluate the health of our system when new vulnerabilities arise. The third recommendation is to enforce requirements that users attempting to submit new algorithms to the Endeavor marketplace must also submit detailed documentation regarding the internal operations of that algorithm. This should be supplemented with a review and vetting process for the algorithm done by Endeavor testers and evaluators. For system availability, the algorithm can be immediately made available to the user, but it will be labeled as verified with a little blue or green check mark only once it passes the review process. Fourth, maintain a repository of living ethics and security documentation with routine meetings for the team to review and update these documents as necessary. We're already doing this. The repository includes risk assessment models such as the DREAD, the STRIDE, or the Linden model, descriptions of AI-based system components such as the intelligent assistant and everything we've enumerated during this talk, and how they map to governmental and professional ethical guidelines, and the algorithm descriptions submitted by users. Fifth, leverage the existing services, resources, and subject matter expertise already available within NASA as much as possible. This will enable Endeavor developers to address the standard system security concerns using solutions already present and evolved within the agency, and to take advantage of the breadth of knowledge embodied by NASA community members to address ethical involved within the agency, and to take advantage of the breadth of knowledge embodied by NASA community members to address ethical and personal risks within the system. Finally, and probably most importantly, pursue continuous AI ethics education. It has become very clear that this area has not been a part of the computer science or data analytics curriculum. And in fact, I'm writing an opinion piece on that right now for the Atlantic Council. NASA has not been a part of the computer science or data analytics curriculum. And in fact, I'm writing an opinion piece on that right now for the Atlantic Council. NASA at large should work towards our workforce, particularly our technologists, becoming well-versed in the basics of AI and ethical ramifications of its use. The benefits of that for a workforce that will be working side by side with AI in the future are immeasurable. We have a longer-term roadmap for Endeavor. Again, to support the NASA workforce, the full implementation of the environment will also contain things like the ability to quickly pull code or scripts from a local machine, Stack Overflow, GitHub, and incorporate it as an atomized function in the ecosystem. It'll include things like the ability to load other data science software like RStudio or MATLAB as 2D screens in this 3D environment and quickly pipe that data between those environments. And it'll include things like the ability to quickly ingest data from unique pipelines and run initial analysis based on user preferences, templates that are custom to the user. But the key isn't to analysis based on user preferences, templates that are custom to the user. But the key isn't to just develop these capabilities that you see on this roadmap. We also want to develop new techniques, some of them AI-based, as well as to understand the ethical ramifications thereof. And we do want to open source certain capabilities, such as some of the fundamental technologies behind the intelligent assistant and algorithm sharing capabilities. And so this fall, we want to work on mapping the ethical priorities listed in the NASA AI ethics framework to quantifiable, concrete metrics concerning the Endeavor system. How do we quantify, for instance, transparency with respect to the algorithms submitted to the Endeavor system? What novel approaches to quantifying explainability in AI can we use to better align with the framework? Instead of high level themes and recommendations, we plan to study and publish results about how to quantify these things in a full ethics report for Endeavor. These results will hopefully provide other groups doing this kind of work, particularly at the intersection of XR systems and AI, an offering of metrics to apply to their own systems. Finally, we recently discussed how some of our considerations apply in the context of XR systems in general. These are elements that we will have to consider with respect to our system, but also with respect to XR systems. The first is looking at physiological impacts to users after prolonged system interaction. The physiological effects of engaging with VR systems for extended periods of time are still understudied, but can include things like nausea, headaches, and disorientation. As the Endeavor system becomes more widely adopted, the likelihood of users experiencing adverse physiological effects after engaging with the system for too long is low, but the impact, if it occurs, is pretty high. One of our interns, Christina Morales, this semester is looking at how we can measure psychometric effects of operating in the environment to better align with our ethical framework. The second is unintended interactions in multi-user environments. Studies have shown that users in a multi-user mixed reality environment have trouble grasping concepts of ownership within that virtual environment and have a tendency to leverage this virtual content to mess with their fellow users. Users have also been known to suffer sociological impacts such as exclusion during multi-user mixed reality experiences. While the likelihood of this risk occurring is low, its potential impact is high due to the immersive nature of VR and the interactions of misintentioned fellow users. The final thing that we want to look at that we think applies across the board is looking at the democratization of AI, which heavily applies to mobile systems like the Oculus that we're using for this. Access and export control violations. This risk centers around the ability for users to access data sets or algorithms that they normally would not have access to, either because of flawed sharing authorization or because data and algorithms in aggregate leak more information than those entities normally would on their own. The likelihood of this happening and associated impact can be high depending on the organization. To meet our digital transformation goals at NASA, we plan to work with the public in a variety of ways to continue the advancement of AI in our society. But like everything else we've done, from going to the moon to exploring the universe, we have to leverage the best capabilities and methods from around the world. We don't get there ourselves. Developers like you help us to get there. And so we need you to ingrain ethics into AI with us, developing methods and capabilities in your own projects for this critical subject. We leave you with a few resources here that will help you get started on this endeavor. Our curriculum on this subject starts here and ends at the edge of an eternal tomorrow. Like always, if you innovate alongside us, we can achieve so much. Welcome to the age of ethical AI. Together, there is nothing we can't do. Thank you.